Good morning everyone. So in this class I am going to explain the differential form. This is your second chapter in your differential geometry. So this is differential forms. Okay. So now look here. A differential form on R3 or E3. So suppose we consider the Euclidean space. So a differential form on E3 is a expression obtained by adding and multiplying the real valued functions. So differential forms means it is an expression obtained by adding and multiplying the real valued functions, and the differentials are dx1, dx2, dx3 of natural coordinate functions of R3 or Euclidean space na consider madidre functions of E3. Okay, this is the differential forms. Differential form is an expression obtained by adding and multiplying the real valued functions. Okay, now look here. So these are the very important notes. So in that first one, the two operations obey the usual associative and distributive laws. So two operations means addition and multiplication. These two operations obeys the associative and distributive laws. So however, the multiplication is not commutative. We know that the multiplication is not commutative, and it obey the alternative rule. So multiplication commutative property na obey madadilla. So that's why we use the alternative rule, or it obeys the alternative rule. So that is anti-commutative property or anti-commutative law. So that is represented as, or that expression is dxi dot dxj, which is equals to minus dxj dot dxi for all 1 less than or equals to I and j less than or equals to 3. Okay, then palirbe note. Okay, then we move on to the second one. A zero form is a differentiable function. Zero form is a differentiable function f. Then a one form is that can be represented as one form like this. Okay, no. So word alli bariyodikkinta number alli represent ಮಾಡಿ. A one form is an expression of the form. Look here. One form can be expressed as f1 into dx1 plus f2 into dx2 plus f3 into dx3. So this is the expression of one form. Similarly, a two form is the expression of two form is f1 into dx into dy plus f2 into dy into dz plus f3 into dz into dx. Similarly, a three form is an expression of the type f1 into dx into dy into dz plus f2, so on like this. Okay, this is the expression of the three form. Similarly, a p form contains the expression of p type means, so p dix means f1 into dx1, dx2, dx3, so on like this. So here p contains 0, 1, 2, 3, so on. Okay. Then last one is, so on E3 or R3, all three forms with p greater than 0 are all zeros. Okay, you should remember this one. Okay, so on E3, all three forms with p greater than 3 are 0. Okay, so these are the important notes. Then we move on to the definition. Look here. Let pi and xi be the two differential forms. Pi and xi be the two differential forms. The product of pi and xi. So now look here. The product of pi and xi is denoted by pi wedge xi. So this is the product of two differential forms, pi wedge xi. So then this product is called as wedge product. So this is the definition and also product of those two differential forms. Okay, just remember this one. Let pi and xi be the two differential forms. Then the product of these two is denoted by pi wedge xi. This product is called wedge product. Okay, next we move on to the example of this wedge product. Look here. The example is, look here. First one is compute the wedge product of functions pi equals x into dx minus y into dy and xi equals z into dx plus x into dz. Okay, so now here we find the product of these two, means wedge product of these two forms. Look here, the solution. So now we consider the pi wedge xi, which is equals to the pi function pi is x into dx minus y into dy wedge z into dx plus x into dz. Okay, now we multiply these two. So look here, the first term x into dx, here z into dx, this can be represent x into z dx into dx plus x into dx into x into dz, that is x square into dx into dz plus into minus minus y into z dy into dx plus into minus minus y into x dy into dz. Now look here, okay, by using the previous notes, by observe those notes. Okay, so on R3 p greater than 0, all dxi's are 0. Okay, look here, when we get the repeated these two, or when we get the repeated dx or repeated dy or repeated dz, then that value so will becomes 0. ಸೊ ಅದು ಕೂಡ ನೆನಪಲ್ಲಿ ಇರ್ಬೇಕು ನಿಮಗೆ. ಯಾವಾಗ ನಮಗೆ ರಿಪೀಟೆಡ್ ಡಿ ಎಕ್ಸ್ ಸೈಸ್ ಸಿಗುತ್ತೋ ಆಗ ಆ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ, 0 ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ಲುಕ್ ಹಿಯರ್, ಎಕ್ಸ್ ಇಂಟು ಝಡ್ dx into dx, these are the repeateds. So then this value will becomes 0. So therefore this value is 0 plus the remaining is x square into dx into dz minus yz into dy into dx minus yx into dy into dz. ಓಕೆ, ಸೊ ಯಾವಾಗಲೇ ನಿಮಗೆ ರಿಪೀಟೆಡ್ ಡಿ ಎಕ್ಸ್ ಐ ಸಿಕ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದರ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ, ಯಾವಾಗಲೂ 0 ಇರುತ್ತೆ. So this is the example for your wedge product. Find the wedge product of those functions ಅಂತ ಕೇಳಿದ್ರೆ ಆ ಎರಡು ಫಂಕ್ಷನ್ಸ್ ನ ವೆಡ್ಜ್ ಪ್ರಾಡಕ್ಟ್ ನ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಬರಬೇಕು. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಏನಾದ್ರು ರಿಪೀಟೆಡ್ ಡಿ ಎಕ್ಸ್ ಐಸ್ ಡಿವೈಸ್ ಡಿಝೆಡ್ಸ್ ಏನಾದ್ರು ಸಿಕ್ಕಿದ್ರೆ ಅದರ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ, ಯಾವಾಗಲೂ 0 ಇರುತ್ತೆ. ಓಕೆ, in the next class we have to learn about some theorems and lemma of the differential forms. Okay, thank you.